Hi folks, welcome to video number 214. This one is on histograms. The keyword or the key phrase I've got for you is frequency density. Now frequency density is how much of something there is per unit of measurement that the data has been recorded in. And the triangle that I've drawn for you is the most useful thing for you to remember on this topic really. Alright, if you want to work out the frequency density, frequency divided by class width, etc. It works like any other formula triangle. So you might be asked to draw a histogram. You will need to calculate the frequency density, if you're going to draw one, by doing the frequency density divided by the class width. Then you draw the bars, the width of each class and the height of each frequency density. The bars will be different widths, they'll be joined together, unlike bar charts. And you may be asked to interpret a histogram and compare some data that you get from one to another. In any case, the formula triangle will help you work out whatever bit of missing information it is that you've got to work out in the question. Alright, so for the first question, number one, we've got to draw a histogram for this following data. What we need is the class width. That is the difference between the numbers in the classes. So I'm going to add on a column here. In fact, I'm going to add on two columns. Might as well do both at the same time. I'm going to add on two columns because we need the class width in order to get the frequency density. And the class width is very easily found by looking at the classes, which are these things, the lengths, right, of something. We don't know what they are. And the difference is 0 to 10. So the class width there is 10. 10 take away nothing. 15 take away 10 is going to give you 5. That's the difference there. 18 take away 15 is going to give you 3. 22 take away 18 is 4. And 30 take away 22 is going to give you 8. All right. So we've got our class width. So what we do is the frequency divided by the class width. Okay, so we can just divide these numbers by these. 5 divided by 10, and now 5 divided by 10 is going to be a half. So 5 over 10, 1 over 2, 0.5. The 8 divided by 5, you could double both those numbers and do 16 divided by 10, which would give you an easier thing to think of there, I think anyway. 8 divided by 5, don't fancy it, but 16 divided by 10, yeah, I'll have that. So that's 1.6. Okay, then we've got 3 divided by 3 to give you 1. 8 divided by 4, that's going to give you 2. And then 2 divided by 8. So they're going to give you 1 divided by 4, 1/4, which is 0.25. Okay, now what we do with those is we plot them up the side. And the scale is there, right? And the scale is already pre-populated, which is all good. Just have to figure it out. I'm going to zoom in and we're going to draw these bars. That's the things we need to draw in the histogram, and we've done it. So hopefully that's not covering too much of the graph. What I'm going to do is I'm going to go up to 0.5 for the first bar there, and I'm going to draw a line that goes across to 10, and then draw a line going down. Alright, that bar represents those 5 things that are between 0 and 10 millimeters in length. We don't know what those things are. Fish, maybe. Who cares? Right, the next one is between 10 and 15. There we go, 10 and 15, that's the bar size. And we're going to go up to 1.6. Let's work out the scale. So each one of these 2 little notches is worth 1 or 0.1. So that there-ish is 1.6, I believe. So we're going to go across there. It's a bit blurry, and obviously you'll be able to draw yours a lot more accurately with a pencil and a ruler in your exam paper. So there's the second bar. We go across from 1 and we go to 18, 15 to 18. So 15, 16, 17, 18 is there. And we go up to 1. That's an awkward bar to draw, to be honest. But there we go, go across. Oh, it's frustrating, but we're getting there. And then we've got 8 divided by 2 to give 8 divided by 4 to give you 2. So we go up to 2, and we are going to start there. So let's just draw that one. Oh, it's a little bit off, isn't it? Never mind. Well, you know what I'm doing. It's got to be exactly in line with that one there. And then we go across to 22, so 21, 22. I think that's where 22 is. And then we draw it down. There's our 22. And then 22 to 30 is at 0.25. So 0.25 halfway down halfway between 0 and 0.5, and then we get that bar drawn there. And what you see is just a representation of that data in histogram form. Alright, I hope that makes sense to you. Maybe we should have the bottom labelled with length as well in millimetres. But that's it. Alright, this, and like I mentioned, these lines have to be as accurate as you can possibly get them. We might not get away with that in an exam, but it is on a computer and it's very hard to draw. So please forgive me. Now, I'm going to zoom out that one because I need to look at the next question with you, and I will erase that, or will erase because I need the other pen up. Now, this histogram in number 2 shows information about all the trains that were late last week. We need to work out the total number of trains represented, first of all. So all we have to do when we need to work out how much each bar is worth is just do the class width multiplied by the frequency density. This is the frequency density, this is the class width, right? So 2 multiplies by, and what we can see there is half between 15 and 20, so that's 17.5. And then we're going to multiply that by 2. Well, that's going to be 35, isn't it? So that is worth 35, that bar, right? This bar is going to be another 2 multiplies by 15. So 15 multiplies by 2, that gives you 30. Okay, and then this one is going to be 3, because 4, that's 7, 4 to 7, that's 3, and that's 10, so 10 times 3. There you go, that one's 30 as well. So whilst they look different, they are actually representing the same number of trains, these bars. It just happens to be this is a different class width to this one. And then this one is 7 to 12, so that's 5, and 5 times 5. Because the frequency density is 5 as well, so that's 25. Now each one of those numbers can be added up. So 25, that's going to be 40, 60, another 60, 120. I believe. So that would be 120 trains are represented in that histogram. In the second part of that question, we need to estimate how many were more than 10 minutes late. So what you do is you go, and I'll just get rid of that there, all that information in case it confuses anyone. This is the second part of the question. All we need to do is go to where the 10 is, here, and just kind of chop it off. And what we've got is just another chunk of the bar to work out how many trains there were. Now it's only an estimate because we don't know how many actually were up this end were late. It could have been 1, right, and it could have been all 25. We don't know, right, between 10 and 12 minutes. We just know that that's the category that they were in, or the class width they were in when the data was collected. So it's only an estimate. So what we do is just the same thing. There's a difference there of 2, 5, 5 times 2, 5 times 2 is 10. We reckon there's going to be 10 trains that were more than 10 minutes late. Okay, now, last question, always tends to be the most difficult, or most complicated, most involved. The histogram shows information about 480 car speeds. How many cars does the first bar represent? The problem that we've got with this histogram that's been given to us, it does not have a frequency density up the side, and that is quite often why it's more complicated. So what we have to do is we have to work out how many cars there are represented in the whole thing. We can do that by working it out using the squares. I quite like this method of doing things. Right? What we can see here, if we split it all the way down here, right, and here, and then across, I'm not drawing these particularly well, there we go, right, we're splitting it into exactly the same size squares. Each one of those squares is going to be worth the same number of cars, alright, so we just need to make sure we can get a whole number of these things that are going on. And what you can see here is that we've got 3 little strips at the top. So we've got 1, 2, 3 strips that would fit beautifully here to make these whole squares. Alright, so what we're doing, we're just ignoring kind of the class width that's in at the moment, and we're saying that these 3 can sit on there, and we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. 24 whole squares, okay? We know that there are 480 cars represented in here in total, so 480 divided by 24. So if you did 48, just frozen, I'll just wait for a second until I come back. There we go. So if we did 48 divided by 24, you would get 2. All right, so we just stick that 0 back on 20. All right, so each one of those is worth 20. Right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 times 20, 15 times 2 is 30. So 300 is what the first bar represents. All right, now I hope that makes sense. It's a nice way of doing a question that's a little bit more complicated. You're always going to be able to do this. It's going to be a nice thing to notice. Oh, look, those 3 little strips, they fit onto there beautifully to make those whole squares. Lovely job. Right. In B, estimate how many cars drove faster than 20 miles an hour. So again, it's the same things we did before. We could go cut it off down here. There's 20 miles an hour. All right. Each one of those squares is worth 20 cars. All right. We know there's 480. So 20, 40, 60, 80, 100. That you might as well just take off of the 480 because that's the ones that were not faster than 20 miles an hour. So the rest of them were. Right? Maybe it's just a quicker way of doing it. So that's going to be 380 cars. All right, and there is histograms in a nutshell for you. I mean, you might get some more complicated things, a combination of questions, maybe comparing with cumulative frequency graphs, maybe adding in estimating the mean as well. But if you combine all of the understanding of the videos that I've made for you and you watch them and understand them beautifully, then you should be prepared to answer any sort of question on this topic. All right, just remember that formula triangle. Thanks very much for watching. Take care of yourselves, look after each other. Bye bye.